Hi, I'm Adri. So I'm going to be talking about our box design. So our box is made up of recyclable materials. As you can see here, it's made up of vanilla card, A4 paper, and this aluminum strap that we took from aluminum can. So first of all, the body is made up of vanilla card because as we all know, vanilla card is thicker, so we have a rigid stand. We have a more rigid stand. And then at the top here, we strap it with A4 paper for us to stick the aluminium strap. So and this aluminium strap will be used for the sensing, for the box to be detected by the sensors. So as the box moves, this strap will be detected by the sensors and the ball will automatically go in. So that's all. Thank you.
Hi, I'm Chang Fui and I'm going to explain the wiring process of the material handling system. So we will start with the relay circuit diagram first. So in normal condition, the relay A is not activated because the current cannot flow through the NPN transistor here. So once you want to activate the relay A, you can provide an output from the GPIO pin to the transistor, and therefore the transistor will allow the current transfer from the positive terminal to the negative terminal and go back to the ground and complete the circuit, and therefore your relay will be activated. So the next one is the valve for the solenoid. It will actually share the same principle as the relay. And the third one is about the sensor. So the sensor will actually consist of 3 wires here, which is the blue, brown and black. So the blue wire will connected to the ground and the brown wire will be connected to the 24 volt of the PLC. So in normal condition, which is the sensor is not sensing any kind of metal plate, the black wire will not have any current. So the 3.3 volt that is supplied from the Raspberry Pi will go through the resistor and go to the input pin of the Raspberry Pi. So in normal condition, your Raspberry Pi will be sensing a true value. So if the sensor is detecting any metal plate, it will produce a black current through the black wire and flowing through 2 voltage regulators, which are to step down the voltage and the resistor and go to the left side of the autocoupler. So the left side of the autocoupler will actually emit the LED light source to the right side of the autocoupler, which is the phototransistor, and the phototransistor will allow the voltage from the 3.3 volt go through the resistor and go through the transistor and going back to the ground. So your input pin of the Raspberry Pi will not sense any value, and this is how actually the sensor works if it senses the metal plate. So lastly, we will go to the complete circuit diagram of the material handling system. So we will go to the back switch here. So the back switch is not connected to the 24 volt, instead it will connected to the 3.3 volt of the Raspberry Pi. So another wire, which is the black wire, will be connected back to the input pin, and another one will be connected to the ground terminal. This is because when the black switch is not pressed, your input terminal will be sensing the value of the ground terminal, which is 0. So once the black switch is pressed, the 3.3 volt will flow through the switch and go back to the input terminal. It will sense a value of true. Therefore, you can control your material handling systems. So the other elements, as discussed earlier, is actually connected to the interface circuits, which has the transistor, the voltage regulators and the resistors. And this interface circuit will connected back to the Raspberry Pi in order to control the full material handling system.
Now I'll discuss about the coding. So first I import rpi.gpio in order to import the GPIO modules. Next I'll import the time in order to have a stop after the sensors are being activated. Next I'll assign GPIO.pin to every components here, and I'll set the mode of GPIO pins as BCM mode. And then I'll set up the sensors and switch as input and the relay and cylinder as output. So first I'll stop the motor first, and I'll assign number 0 to the count. Inside a while loop here, first I'll extrude all the cylinders, and if the black switch are being pressed, so the condition here become true, and then we will go into the while loop. And first, if the left sensor is being activated and the conditions become false, and we'll collect 2 balls. Okay, and as you can see here, the I in range 2 in the for loop here, we'll collect 2 balls and the number of counts will increase to 2. And then right sensors are being activated and same process happen. And the count now becomes 4 and the box will move to the right for a while and then the box will move to the left and same condition happens. Right sensors is being activated, count becomes 6. And then the left sensors is being activated and the count becomes 8. So now the count becomes 8 and the while loop is break. Since the count is equal to 8, then we will stop the motor and clean up the GPIO pin and the process is completed. Thank you.
Hi, I'm Ahmad Fahmi and I will explain about the material handling process. So at this moment, when the black switch is pressed, all the cylinder will extrude first and the box will start to move to the right. When the box reaches the left proximity sensor, the top left cylinder is retracted. Allow the one ping pong ball drop to the bottom left cylinder. The top left cylinder is then extruded and the bottom left cylinder is retracted, dropping the first ping pong ball to the box. After retracted, the bottom left cylinder will extrude to support the second ping pong ball that drop when the top left cylinder is retracted. The bottom left cylinder will retract to dropping the second ping pong ball to the box. After that, the box continue to move to the right until the metal plate at the box sense the right proximity sensor at the second or right cylinder. At this moment, 2 ping pong ball again will be released to the box. After 4 ping pong ball were collected, the box move again to the right and at one point, the conveyor belt will reverse back to the left to collect the 2 left ping pong ball at the right cylinder. Lastly, the box continue to move to the left until it reaches the left cylinder again to collect the 2 remaining ping pong ball and the box will move back to the position where it is start to begin.
From this project, I'm happy that I can learn how to use a Raspberry Pi to control the material handling system, such as by controlling the movement of the conveyor belt and also the extraction and retraction of the cylinder. So that is a part of things that I cannot learn from the textbook, but from the experiment.
Okay, so what I learned from the project, first is the Raspberry Pi. Okay, now I know that the programming is really important in mechanical industries because the Raspberry Pi is something that control everything like the conveyor belt and also the pneumatic valve.
So first of all, I would like to express how grateful I am to be a part of this group and to experience this project together as one group. And I learned a lot of things from this project, especially like from what the Raspberry Pi itself can be used for so many applications, and also the wiring process that cause a lot of errors during the conducting of this project. So yeah, that's all.
From this project, I learned about the selection in the circuit and how should I integrate all the components into the circuit, like the transistor, cylinder, okay. And after that, I also get to know that Raspberry Pi can act like a microcontroller that can control the whole machine by utilizing the cylinder, motor, and also the switch.
From this project, we get a lot of experience. One of it is the use of Raspberry Pi to help us to achieve our objective in this project. And also we realize the importance of Raspberry Pi in the current maintenance industry.